We are starting a big section here on solving equations. And we'll be spending like a week solving equations. I'm not going to do number 1, but I am going to do number 2. So this is the expand and condense that we learned last Friday. And being able to condense is super important. And it's a necessary step to solving logarithmic equations. And so if I were to condense this, what would I do first?
You check what thing it is.
Move the powers up. And so that'd give me log base 4 of x cubed plus log base 4 of y to the 4th minus log base 4 of z to the 4th. And then I'm going to condense that to that single log base 4. And then we just have to decide what goes on top or bottom. So x cubed goes on the top because it's positive. Y to the 4th goes on the top. And z to the 4th goes on the bottom. And that's a very simple way to condense using our log properties. Okay, so we want to be able to do that today in conjunction with the ways we've actually already learned how to solve logarithmic equations. One of those ways was the one-to-one property. So the one-to-one property said if log base b of u equals log base b of b, then what? U equals v. If the bases match, then the arguments must match. That's the one-to-one property. The other property we know is if we have, like, I don't know, log base 3 of 9 equals 2. So if you have a single log, how do you drop a log? You give it a swirly. So you give it a swirly, and that's the other property we already know. Now, maybe you had a super fancy math teacher before. I'm not so fancy.
I had Miss Goodnow.
I'm so fancy.
I have Miss Leanne.
Okay,
So maybe your math teacher used the word, oh, we need to exponentiate both sides. Yeah, no, I said, how do you drop a log? You give it a swirly. And that's sort of more me. All right. Which is like totally terrible when I buy cards for my husband. Like, because I am just a jokester, but he knows that I'm a crier, so he finds the cards that make me all cry. But I want the ones where it's like, hey, babe. Step 1, solve the log equations and check your solutions. Check, 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 check.
Check 1, 2, 3.
Okay, you must check. These are log equations, and if you have log of x, it has a domain restriction. Whatever's inside that argument must be greater than 0. Remember, we have vertical asymptotes when we have log graphs. We cannot take the log of a negative argument. Okay, the argument is what's inside those parentheses. So be careful when you're solving log equations. They come ripe with problems. Okay, so what property can we use to solve the first one? One-to-one property. If the logs match, then 4x minus 9 must equal x minus 12. So I'm going to subtract an x and add the 9. And I get x equals -1. Now, -1 is a perfectly fine number, but we need to check it. I'm going to plug it back into the original. Always, always the original. Natural log of 4 times -1 minus 9 is supposed to equal the natural log of -1 minus 12. Is this allowed?
Yes. And it works.
Now, wait a minute, does it? This is the natural log of -13. This is the natural log of -13. It balances, but is it allowed?
No, because
No.
it's negative.
We cannot take the log of a negative number. We cannot take the natural log of negative 13. If you try it, it's going to give you a non-real answer. Can't work. Does not compute. Okay? This is a false solution. All right. Remember, when in doubt, graph it out. You could plug the left-hand side in Y1 and the right-hand side in Y2. You have a natural log button. You can use the button and graph those two sides. They will never intersect. Okay? All right. Letter B, 6 times log base 3 of x plus 12 equals 12. What do you want to do?
Oh, wow. Move the 6.
Move the 6.
Six.
We got a couple of options. One option is we can take the 6 and we can move it up to its power position. Is that the only option?
Can you divide it?
You can divide it. It's 6 times the log. Now, with knowing that, what would you want to do?
Divide it.
Divide, absolutely. I would much rather the divide by 6 than worry about a 6th power. So log base 3 of x plus 12 equals 12 divided by 6, 2.
So the log stays the same?
Yes. Now, how do we solve this?
Move the 3.
Swirly. How do you drop a log?
How to swirl.
Swirly. All right, because this is not the one-to-one property, so we're going to start with the base, circle around and pick up our power. That's 3 squared. And that's supposed to equal x plus 12, the argument. Notice that you did have to isolate the log before you could give it a swirly. All right? Isolate the log before you give it the swirly. So we have x plus 12 equals 9. And I'm going to subtract 12 so I get x equals negative 3. Is that okay?
No.
6 times.
Negative.
I'm going to go plug it back in. Negative 3 plus 12 is supposed to equal 12. 6 times log base 3 of 9. Does it equal 12? What is log base 3 of 9? 2.
Times 6.
Times 6 gives you 12. Yes, it absolutely checks out. All right. So you can plug that in and make sure that it works. Log base 3 of 9 is 2. All right, next. Those are the easy ones. Log of 5x plus log of x minus 1 equals 2. What do you think we need to do here? Condense. Very good. I don't have any way of solving when I've got multiple logs floating around. Okay, so we need to condense first. That is why we learned those properties on Friday. So we are condensing to a single log. So log of what? What property allowed me to add the logs? The product property. So we have a product here. 5x times the x minus 1. I'm going to go ahead and distribute that. So I have 5x squared minus 5x equals 2. Now, how do you solve for x?
Swirly.
Swirly. Swirly. How do you drop a log? Swirly. What's the base? 10. Very good. So again, we give it a swirly because we cannot solve logarithmic equations. We rewrite them in exponential form. So I have 10 squared equals the argument, so 5x squared minus 5x. What is 10 squared? 100, not 20. Nope, not 20. Favorite mistake. Right, 20. Okay, it's 100. So how do you solve when you've got a quadratic? Factor factor. So I'm going to set it equal to 0. So I have 5x squared minus 5x minus 100 equals 0. And then what can we do? Take out a 5. Very good. If I take out the 5, I have x squared minus x minus 20 equals 0. And then we can factor. X times x is x squared. What times what is negative 20? Negative 5 and positive 4. So we get x equals 5 for a possible solution, and x equals negative 4 for a possible solution. One of these does not work. Which one? Why does negative 4 fail? Not because it's negative. When you put it back in, the argument becomes negative. So 5 times negative 4 plus the log of negative 4 minus 1, this becomes the log of negative 20. Negative 20 is the issue. And here, negative 5 is an issue. We cannot take the log of negative arguments. I guarantee you I'll give you one where the negative value works. Okay? Just to trip you up. All right. So negative 4 doesn't work. 5 does. All right, letter D. What do we need to do first?
Condense.
Condense. Nice word. Condense.
That Ellen.
Don't ever.
All right, so I'm going to condense down to a single log. What property allows us to subtract the logs? The quotient property. What goes on top? 2x plus 1. What goes on bottom? All right. We condensed it to a single log. How do you drop a log? Swirly. What's my base? All right. So we're going to give that a swirly. So I have 10 to the first equals my argument, which is 2x plus 1 over x minus 2. And, how do you solve that?
You multiply both sides by x minus 2.
Multiply by x minus 2. Yeah, you can think about cross multiply if you want. 2x plus 1 equals 10x minus 20. And let's see, I'm going to subtract 2x. And I'm going to add 20. And I'm going to divide by 8. So I get 21 over 8 as a possible solution. Now I do want to check my answer. And since these are just log-based 10s, I can plug it back into my equation and just use my calculator to check. So 2 times 21/8 plus 1 inside my first log minus log of 21/8 minus 2. What is that supposed to equal? 1. And it does. Okay. You can plug into original. Do not ever plug it into a condensed equation. When you plug into a condensed equation, by nature of the properties that we have, it eliminates the problems. It's how we were able to solve it anyway. So you always go back to the original. Okay? Questions on either of those? Last one. Where's Ellen? She needs to give me $1,000 million.
Very nice. Much fun.
Ellen's like Oprah.
All right, ladies and gentlemen, what do we need to do first? Pendants. So, to a single logarithm, is this the quotient property or the product property? Quotient. What goes on top? What goes on bottom? All right. Now, how do you drop a log? Give it a swirly. Well, what's our base? Very good. Ladies and gentlemen, please remember natural log is the same as log base E. So we have our base of E, and we're going to give it a swirly. So I get E squared. What is E squared? 7.3-ish something, yeah. Remember, what is E?
A number that 2 and something.
Two, almost 3.
Not quite 3. What is E?
2.7.
Not quite 3. What is E? Not quite 3. Okay. So this is really just a not quite 3 being squared, right? All right. How do you solve this? Cross multiply. Yes, very good. So we have x equals e squared times the x plus 1. What should I do with the e squared?
Definitely.
It's just a number. It's just a number like 7.3-ish. What should we do with it? Distribute it. Absolutely. Let's distribute it. E squared x plus e squared. How do you solve for x?
Divided by x.
I've got a lot of x's. What do they need to do?
What?
You move the other. Make it.
Wait, you subtract it.
Subtract what?
The e squared x.
Subtract the e squared x is correct. We have a couple of things here that have x's in it. They're friends. They need to be on the same side.
It's because it's
All
a
right.
number, so it's like
So it's like a 7.5x. All right, we got a 1x, we got a 7.5x. So I have an x, and I'm going to subtract the e squared x. Now what do you see on the left? What do they have in common? Oh, there's a GCF here.
subtract that or divide that.
Take out the greatest common factor. You take out the x. What's left behind?
Oh.
1 minus e squared equals e squared. And then now, how do you get x by itself? You can divide by all the garbage. Divide by 1 minus e squared. So we have x. My pen is dead. X equals e squared over 1 minus e squared. Is this number going to work?
No.
It's a 0. We don't know.
We don't know. Can I approximate this number? I can type this number into my calculator. It is a number. So I'm going to do that. E squared divided by the entire 1 minus e squared. So make sure you use parentheses. 1 minus e, whoops, that's not e. E squared, whoops. There we go. All right. Is negative 1.1565 ... Is that an answer that will work?
No.
No, because when I plug it in, you can even do this. Natural log of the answer. When I plug it in right there, non-real solution. No dice. This is no solution. The other thing that you could do, again, when in doubt, graph it out. You can always, and I'd just like to remind you of this quickly, is you can always put the left-hand side in y1, especially since you all have a natural log button, okay? And you can put the right-hand side in y2 and calculate where they intersect. This is our little natural log of x graph, and here's your line y equals 2. Are they ever going to intersect? No. All right. No solution. All right. Do you guys have any questions for me?